2-4B, we are doing more with variables on both sides. So this first question is review of what we did on Friday, just to get it fresh in your heads again. And then I'm going to give you two situations where you don't get what we would call normal answers. They're special cases, okay? So special situations when we're solving with variables on both sides. So this first one, let's say we have this set up. Okay, so here's our problem. What do you think the first thing you should do in this problem is? Right. Can you give me a word for what? Distributive property. Yes. Is that what you were going to say? So we're going to distribute this 2 to both of those. So what's 2 times 5x? 10x. Okay. And then 2 times a -1 would be -2. Oops. So it's 10x minus 2. Bring down your equal sign. And then what do you do on the other side? Same thing. You're going to distribute. So 3 times x and 3 times 11. So you would get 3x plus what? Plus 33. Okay. So here's our problem to solve. Now, like I said on Friday, you don't have to do it one particular way. You could move either of your x's to the other side of the equation, but which one would I do? The 10x, would I move the 10x or the 3x? The 3x, right? Because we would like to just keep things positive so we don't have that extra step at the end. It's not wrong if you move the 10x, but the simpler version is to move the 3x. So I'm going to take away a 3x from both sides. Remember, here's my equal sign. So if I subtract 3x on the right of my equal sign, I have to subtract 3x on the left of my equal sign. So 10x minus 3x is 7x. We still have a minus 2 over there. Bring down your equal sign. The 3x's are now gone, and we're left with a 33. What would your next step be? Add 2. Right, we're going to add 2 to both sides. So this goes away. -2 plus 2 is 0. We get 7x equals 33 plus 2 is 35. And then what's your last step? Divide by 7. Okay, so x is 5. How can you check if you have the right answer? You would take that 5 and you would plug it in here, and you would plug it in here and just check what you get. So 5 times 5 is 25 minus 1 is 24. So this is 2 times 24, right? So that's 48. 5 plus 11 is 16, and 3 times 16 is also 48. So you know your answer checked out. Okay? Questions on that? This is not new. We've done this. Are you good there? Yeah. Okay, the new stuff. There are 2 different answers that you can get. One is called an identity. Okay. An identity is an equation that is true for every value of x. Okay, so in other words, it doesn't matter what I plug in for x, I will get a true equation every single time. Whereas normally we say, solve the problem, x equals 9. Okay, this is saying x could be 3, x could be 7, x could be -16, x could be 1,000,000, and you're still going to get a true equation. Okay, so that's called an identity. An example of an identity would be something like this. If I get x plus 1 equals x plus 1, okay? No matter what I plug in for x, my equation is true. If I plug in 1,000,000, 1,000,001 equals 1,000,001, right? They are exactly the same. The way I always tell people to think identity is they are identical, right? My left side and my right side are identical. It's an identity.
What does it mean identical?
Identical is exactly the same.
Like the trees?
Yeah, like identical twins that look exactly the same are called identical twins, right? Another example could be something like this, right? 15 equals 15. So your variable went away, but your two numbers are exactly the same. So those would be considered identities, okay? The other option, instead of an identity, is if you have no solution. And no solution means no value of the variable, we're just going to say of x right now, will make the equation true. Okay, so no matter what you plug in for x, it's not going to work out. And a situation like that could be something like this: x plus 1 equals x plus 2. No matter what I plug in for x, 13 would give me 14 equals 15, right? If I plug in negative 2, I would get negative 1 equals 0. Not true, right? So nothing, this will not work out. It is no solution. Or if you end up with numbers like 16 equals negative 13, okay? That is no solution. That's not true. If it's not true, it's no solution, okay? Questions on that?
No.
Thank you. Okay, so here's what we're gonna do. I'm just gonna lay it out for you. Okay, let's do this. I wanna know, does it have one solution, an identity, or no solution? Okay, if I give you a problem and once it's solved, it looks like this: x equals 13. Is that one solution, an identity, or no solution? That's one solution. When your variable equals a number, right? That is one solution. Okay, what if I came up with 13x equals 13x? That's identity. They're identical, right? They're exactly the same, which means no matter what you plug in for x, you're going to get the same, a true solution, okay? What about if I give you 2y plus 3y equals 5y? That's an identity, right? This would say 5y equals 5y. That's identity. Okay, what if I say p plus 3 equals p minus 3? That would be no solution. Those are different. And if you try to solve it, if we took the p's away, it would say 3 equals negative 3, which is not true. So that's no solution. Okay, what would this one get you? X minus 9 equals 2. That would get you one solution because you could solve it, right? Add 9, and it would say x equals 11. So that would get you one solution. Okay, does that make sense? Okay, let's solve a few. Example 2. If I give you 10x plus 12 equals 2 times 5x plus 6, okay? I want to know what your solution is. So what do you do first? You're going to distribute, okay? So distribute the 2 to both of these, and you would get 10x plus 12 equals what? 10x plus 12, okay? Then what? You can say right now your answer. What if you don't notice right now that they're identical? Could you keep solving?
Yeah.
You could, right? I could subtract 10x from both sides and I would get 12 equals 12. Still identical, still an identity. But if you get to a point where your two sides are identical, you don't have to go any farther, okay? We would just say this is an identity. okay? If you want to keep going, you by all means can keep going, but you don't have to. How about this one? 9m minus 4 equals negative 3m plus 5 plus 12m. What are you going to do first in this equation? Take the 3 and the 12. Okay, now here's my question, because this is where a lot of people get confused. Here's our two sides, right? You have a left side, you have a right side. So this is a negative 3m, a positive 12m. Am I adding 3m here to put it over here? No, right? They're on the same side. You don't do the opposite when they're on the same side of the equation. Instead, you just combine like terms. So negative 3m plus 12m is what? That would be 9m. So we end up with 9m plus 5 on the right equals 9m minus 4 on the left. Then what? If you take away the 9m on both sides, this is 0, this is 0, you're left with negative 4 equals 5, and that is no solution, right? That's not a true statement, so we say no solution. Okay, does that make sense? Okay. Last one. Let's say we have 3 times 4b minus 2 equals negative 6 plus 12b. What do you do first? How do you solve it? Distribute, right. We're going to distribute the 3 to both of these. So 12b minus 6 equals negative 6 plus 12b. Now what?
You added the 12b plus.
Okay, so you have options here. You could move the 12b, right? If we're going to move the 12b, do we add or subtract? You subtract. You do the opposite, right? Because here's my two sides. If I want to get rid of it on the left side, then I got to get rid of it on the right side by subtracting. So this is 0, this is 0. We're left with negative 6 equals negative 6, which is what? That's an identity. When they're identical, it's identity. Okay? Or maybe you saw it here already. It sounds like a couple of you did, right? 12b, 12b. Negative 6, negative 6. So even though they're in a different order, they are identical. It's just the commutative property, right? So you could stop there at the red box and say identity, because they are already identical there, okay? Any questions on that? Okay. That is what you are doing for 2-4b.